Yeah, so today I'm going to be talking about stateful processes in Elixir, which is probably something that you've used whether you know it or not. If you've used Elixir a lot, you'd know it. If you're new to Elixir, you may not have sort of realized some of the deep stuff that's going on under the hood that's really cool. So if you've looked through Elixir code, you'll have seen something that looks kind of like this. And if you've come from an OO background, you're going to look at that and say, okay, it's a thing. How's the contrast? Is that readable to people?
Okay.
I might turn the other light off. Yeah. Okay, cool. So if you've seen that, it looks kind of OO. It looks sort of like we've got an object there. We're creating a thing object with the start link call. And then we say my thing do stuff and something something. And yeah, if you're writing Ruby or Java or anything else, that looks fairly obvious what's going on. Thing is, in Elixir, it's not quite the same thing. So short version of this talk is how do you do objects and mutate data in a language that doesn't have objects and doesn't let you mutate data. So if you've gone Googling how to do anything in Elixir, you'll probably see something like this. Like, how do you do anything? It's like, yeah, just use a gen server. It's like, okay, cool. What is a gen server and why, and what does that even mean? So essentially, it's really easy. It's just a stateful active process that uses tail recursive functions accepting async messages applied over immutable data. It's really easy. We've got that, we can go home. Okay. But I kind of look at stuff like that and I don't really, can't blindly follow a recipe. If someone says, hey, just use gen server and do this thing, it'll work. I kind of need to know what's actually going on under the hood. If you have like a thing that says, hey, just use this magical import statement and it'll set up all the stuff for you, I'm like, okay, yeah, but what does that code do? What's that magic happening there? So I need to learn it, I need to internalize it and get what's going on and why. So I'll dive down those rabbit holes and kind of build up a mental model of that. So the one goal for today out of this talk I want everyone to get is basically how do stateful processes work? Enough for so if you see Elixir code that says use gen server in the wild, you'll have an idea, like a mental model of how that's actually doing something. So we talked about Joe Armstrong before from that's a screenshot from the Erlang video. And basically it's just Joe picking up the phone, the 1980s phone, and calling another guy. They kind of say, hello, Joe. And that's basically the whole video. But it's showing off Erlang that's running the telco switch. That's the cool thing about it. So yeah, he recently passed away, but the contributions he made to the community were really profound. He's kind of one of the few programmers I could say he's actually really changed the way that I think about code and the way that data works and the way that concurrency works. The thing he was really focusing on when they were building Erlang was not the concurrency, not functional programming, not any of that stuff, just fault tolerance. So how do you make things handle crashes and carry on? And then you can kind of find out that a lot of the other things fall out of that. So Erlang is optimized for fault tolerance. That leads to isolating data. So you have data that's sitting in a process and nothing else can touch it. And then that process then is immutable. So you have something and you've made a change to it, you can't change that thing after you've done it. You can only transform it and apply a function to build another thing, which leads you to functional programming, which leads you to not mutating state like you do in an OO world, so or an imperative world. So rather than saying, here's some data, do a thing, change the data, return the result, it's like, here's some data, do a transformation, do another transformation, do another transformation, then return the result of that transformation, but your original data is unchanged. So Elixir is just basically a wrapper around Erlang. Like, it's really a superset of the same code. It compiles down to the same VM bytecode, and it runs on top of it, so it has exactly the same semantics. And that's kind of shares with Erlang is that it's not a pure functional academic language. It's actually about being resilient and being fault tolerant, and all the functional programming features fall out of that kind of focus on doing those requirements. So first we've got to talk about what do we mean when we say state. So state is just, you know, the stuff in your program. It's what you work with. So that's your raw material that you're building your code out of. So your data, stuff that changes, it's what you got to work with. And then we talk about what does stateful mean. And that means you're keeping the data in memory somewhere. You're hanging on to a reference to it. I mean, data is always in memory. It's never not in memory because it needs to be in memory, otherwise you can't do anything. But it's sort of conceptually, there's like, there's a heap somewhere and that's off from where your code is doing stuff. So you can create this thing, put it over there, do some work, something else picks it up, does some work with it. That's not what we're doing in Elixir. We're not saying, hey, we're putting a thing over there and then coming back to it later. What you've got in your function, that's what you can work with. In imperative languages, that's a different story. So talk about then what is stateless. If we're saying stateful is that thing, stateless is the opposite of that. So you're not keeping any data anywhere. You're just passing it from function to function. So you have something where you input to the system, you'll do something with it, transform it, maybe pass it to another function. And if you're doing it functional programming, you're doing stateless because that's how most functional languages work. Probably. Some let you cheat. Elixir lets you cheat too, but you shouldn't. So you can't have state and you can't mutate state. So what do? So you have functions. So you do some work and then what you can do is call yourself with the change state to do more work and repeat that. That's how you do a loop forever until you're done potentially. So you could have like a loop that just keeps going and going. Do some work, recursively call yourself, pass it back, call yourself again, pass it back. And that would look something like that. So say we're making like an imaginary shopping cart in Elixir. And we've got a fairly simple thing there. So got a shopping cart module that looks sort of like what you would see in an OO language. We've got an init function that's like a constructor, gives you a new thing. That new thing just happens to be represented as a list. So the representation of that's fairly basic, but we don't care. We've kind of encapsulated it inside everything that this module does. And at the moment, the only thing we can do is add an item to the cart. And we do that just by saying, okay, we have an add item function that you give it a cart and you give it the item you want to add to it. And we just put the item at the front of the cart. So to use that, it's pretty simple. We just say, okay, let's create a new cart with the init function. We add an item for milk, add an item for bread. If we look at our resulting cart at the end, we've got a milk and bread. That's what we added to it. Any questions about that just before we move on? No. I'll probably coding in the presentation software, which doesn't actually run. Good spot though. Yeah, you are paying attention, so that's good. Which is cool, but that is just a purely sequential thing. There's no way to share that between processes. So if you've got a shopping cart here and I want to access it from a different thread over here, or a different process over here, there's no way to do that. So you don't get any benefits from multi-core systems, you don't get any concurrency benefits, and most importantly in the Erlang world it's not fault tolerant. If that thing crashes, it's gone, and it'll actually be running in basically sequence with everything else that operates on it. So if there's a bug in your shopping cart logic, it will basically take down the entire thing that's using that, which is probably not what you want. So we need a way to do shared state, but we don't have shared state, we're not allowed to do that. Not safely anyway. If you're in other languages, you could have threads and you could have shared state and you could have those threads accessing that shared state and you're going to probably end up in a world of pain before long. Anyone here done shared state in Java or one of those languages? It's not fun. Still have nightmares. So if you can't have shared state, you have tail recursive functions and processes. So when we talked before about having a function that can call itself and give its state to itself over and over and over, that's basically what we can do in Elixir. So what we've done with our shopping cart here, we've added a count items function. So there's our cart and we've got count items. So this is one way you can implement this by hand. Don't write this code because there's stuff built into Elixir to do exactly this for you, but I'm just showing off how this works under the hood. Like if you're writing this from scratch, this is what you do. So count items at the top calls count items with the cart and an initial accumulator of 0. And then that calls a private function count items, which is actually a different function because it takes 2 arguments. And that's got two clauses. One is the list, and the other one is the accumulated count. So the first one is the termination clause. So when we've got an empty list, we just say the count is whatever our accumulator was. Second clause, we said, okay, pull the first item off the cart, and then recursively call ourselves again, adding 1 to the count. So each time you step through that list, you're going to pull 1 off the front, add 1 to the count, and then when you get to no items left in the list, that's what you return. So in our example before, we added milk and bread. Our count items returns 2. Any questions about that before we move on? Okay. So that one's cool, but it's still not a separate process. So you still can't use that from anywhere else, which is where processes come in. So what we've done here is hand-rolled, basically managing the process. Again, don't do this, but the talk's going to go and show you what you should do a bit further in. You can do this, and this will totally work, unless I've got milk and bread around the wrong way, which is possible. Excellent. So what we've done here is we've got a start function, and that spawns, it basically just calls spawn on the loop function. And spawn will start a totally separate process. So running concurrently to our current thread of execution, it'll say, okay, start a thing over there that's just running our card. And that starts a loop function. And what that loop is doing is just calling itself around and around in circles. But it's got a receive block in there, and a receive will just sit there and block until it receives the messages that it wants. So if you've got one process in Elixir and you want to send a message to another process, you can do a send operation, and then the receive and the other process say, hey, cool, I got a message, so I'm going to process that message. And that's exactly what's happening here. So we've got our loop, and it only has 2 messages that it receives. One is an add item that gives you the item that it wants, and the other one is a count items, which is like a request. And it receives the process that requested the count. So the add items is exactly the same as the code we had before. It's in line. So we've got our cart, and we're adding the item that we just received to the cart. Then it calls loop again. So that's how recursive process going around and around the circle. Count items, same deal. It will basically do the count items, which I've not included here, but it's the same logic of count items, figure out what the count is, and then send another message back to the first process to say, hey, here's what the result of count items was. Then it calls the loop again. So if we run that, we start a shopping cart, we send it the cart a message for add item, send another message for add item for bread. Then we want to send it a message to say, give me a count of items, return the message back to self, which is me, and then we receive the message coming back. So it's messy, but that works. Which is cool, but there's a lot of boilerplate there. What's that?
The previous one was sending that message to the card, but receiving operation in the card.
Sorry, which one? The
receive one.
At the bottom or in the loop?
Yeah,
down the bottom. Yeah, I mean, this is just running like an IEX. So if you just started up this as just loaded like an elixir.exs file and put all that code in there.
But I mean, the send, I tell you that's sort of sending the message to the card.
Yeah, yeah.
Not class thing that we have by receive. You're not mentioning card there, so it has to know that we're receiving that thing from the card.
It doesn't. So this is receiving it from anywhere. So if it receives any message that says count response, yeah, anyone, it doesn't have to be a cart that sends that back, it could be anything. In practice, when you're writing these kind of things, you'd have a reference, which is like a unique thing to match on.
Oh, it's not voiding, it's like the current context, like just sending someone back to the current context that you're in. Is that?
It's just, the process is just sitting there. So a process has its own mailbox that is effectively global. So if you have a reference to a process, you can send a message to it. So that is essentially, yeah, you can call receive from anywhere and that will match on the thing when it's coming in.
Right. The receive only works with the send above it. It's just ask the message to get sent back.
Like a self sending.
Yeah. So the line above it says to send it back itself.
Yeah.
But the receive will sit there and block. Like even if there's no message in the queue.
Yeah.
So if there's a message there, it consumes it straight away. If there's no message, it'll sit there and wait until it gets that message. That's how the loop works. So the loop would actually run infinitely if there's nothing there, but it sits there in blocks until it receives an add item or a count items. Does that one make sense to people? Okay, cool. So that's cool, and it works, and we've got things in a separate process, and it's isolated, but it's a lot of boilerplate. So if we want to pull out some abstractions from that, so we don't have to write that every time, what would that look like? Something kind of like this. So here's a generic server for a stateful process. So maybe a little bit small. Is that readable by people? I can't talk through. This is like the worst slide. This is the most stuff crammed on the screen. They get smaller after this. So what we've done here is created like a module called myServer that will do all of that plumbing for you. So it's got a start method, a start function that takes a module, which is like a callback module that will contain your business logic. Then it spawns and it says, okay, call apply, which is just calling an arbitrary function on that module, which would be the init function. And then after you've initialized some data state from the callback module, give it to the loop, which is implemented inside here. And then the loop is exactly the same as before, except instead of having specific add an item and count items, we have a generic way of doing a cast, which just says something has sent me a message, I don't need to respond to it, and call, which is like a blocking thing, something sent me a message, I'm going to do some work, send a response back to that message. So when it says cast, it's not cast as in like a type system type of thing, it's just cast as in, hey, I'm casting some data your way, I don't care if I get it back. Call means I'm calling you, I'm going to wait for your response. So the add item is a cast because the caller doesn't care what the result of that is. And the count items is a call because you need to get the number back from the call from counting the items. So essentially it's doing the same thing. So it's just doing some callbacks in there that it'll give to the other thing. And it's got some convenience functions in here for call and for cast. And that's essentially the external API for users that this thing will actually talk to. So seeing that in practice, our shopping cart gets way simpler. So we've turned it into this. So to initialize our shopping cart, we just, our init function is an empty list again. That's our state, which is the items that we have in our shopping cart. And we've defined two callback methods. One is handle cast, which is the exact same implementation. Here's a cart, which is our state, and we get given an add item message with an item. We put that in the cart. And we've got a handle call, which is when we get given a count items message. And then we just call that logic again to count the items and return the result back to the caller. So to use it, we use our myServer module, and we give the shopping cart as the callback. And then we can use myServer cast for adding milk, myServer cast for adding bread again, then myServer call to get the count of the items. And that is basically what GenServer is. So whenever you see GenServer, it's essentially that under the hood. Like that's what GenServer is. Basically doing that loop for you, it's doing the callbacks that your module implements, and then it's got a call and a cast for doing all the plumbing and sending your messages. So when you see use GenServer, that's what I want you to think. Like it starts a process, and then it gives you some convenience functions for talking to that process and for maintaining state. There's some other bits and pieces around there, but I kind of won't go into the details because it gets kind of esoteric around fault tolerance and whatnot. So if we convert our code to not use myServer, our hacky half implementation, we actually do use GenServer, the proper one that's built into Elixir. It looks sort of like this. And that's almost identical to what this version here looked like, right? So I've got a handle cast, we've got a handle call, we've got an init. And there's some plumbing in there. You've got to tell it a thing is a no reply or a reply because there's different logic you can do there. You've got some more options. And you use it exactly the same way. So you start a GenServer with your callback, and then you send a message to it with a cast, and then do a request with a call. And that works. That's cool. Convention is usually to give it a nicer API though. So you'd have your callback module look something like this. So you'd still use GenServer, and you'd have some nice functions that you can call. So it's a bit more, the actual UX of that for the calling API is a lot nicer. So we've got a start function. We just have a plain old add item, and we have count items. And then our shopping cart is starting to look a lot like it was before. So we start it, we add an item for milk, we add an item for bread, and then we do a count on it. which is cool. But any questions about that? Any other Gen server bits before I move on? Nope. We have lost a few things in there though. So the one thing that really I don't like about that is that all the Gen server logic is mixed in with your application logic. So that's how we've got Gen server start in there, Gen server cast, Gen server call. And in this one as well, all our application logic is intermingled with their casts and handling calls and replying to it. So we've actually entangled a lot more complexity into the logic of what this is doing. So we've got our essential business logic that we had originally, we've kind of hidden that with all this other Gen server plumbing. So it's harder to test that thing in isolation. You can still test that fine, but it means you've got to start a Gen server, which is a simple process, which is introducing concurrency, so async testing can get weird. If you just want to say, hey, here's my business logic, I want to test that business logic, that gets harder. And it also means messages are flying back and forth, so it can get harder to reason about. You get race conditions coming in, blah, blah, blah. So another pretty common pattern you see coming up quite a lot is splitting it up into three different modules. So you give it an API module, server module, and an implementation module. And they all have different responsibilities. So this is something that Dave Thomas, Bragg Dave kind of blogged about, and something that's been picked up and used in quite a few places, and it generally makes things a lot nicer. So your API class is exactly what we saw. That's the bare module. So that's your front thing. So that would just be shopping cart. And then that gives you simple things for starting a shopping cart, for adding the item, for counting the item. You have a server module that will do all the Gen server plumbing, back and forth, and all the casts and the calls. Then you have an implementation module. And that's where all your business logic lives. You can make that thing nice and tight and concise. So if we split that up, here's our API module. And that's literally just talking to Gen server. So it's starting Gen server with our callback, it's adding an item, and it's counting the items. And that just delegates off to get Gen server to do the work, but it gives a nice UX, hiding the Gen server details from the world. Then our server is doing the actual work of, that's our callback that we give to Gen server. So this here handles all the messages coming in, responds to all the messages going back out, and it delegates down to our business logic class, which is our shopping cart implementation class. And our implementation class looks something like this. So that's got to create, it's got add items, count items, blah, blah, blah. And if you've been paying attention, you'll see this one here is exactly like almost character for character, the same as what we had at the start. And that's the kind of nice thing about doing this pattern here, because you can take something that's got plain old business logic and then wrap it up, put it in a process, and yeah, treat it as a concurrent thing that's scalable and fault tolerant. So what did that buy us? It's like a lot of round tripping to basically get us back to where we started from. The big thing is that thing is fault tolerant now. Like it's isolated, it's not part of our core thing. That can live off in a separate place in your application. It's a process that's running side by side. Entirely possible that thing could crash. It's on its own supervision tree. And that thing can be restarted from a persistent store like a database or whatever else. If it is making network connections and the network dies, cool, it can just go away, you spin it back up, do the task again, and it's isolated. So it's isolated and fault tolerant. Because it's a separate process, means we can use multi-core. So one shopping cart, not a big deal. If you had 1 million of those sitting in memory, that's a big deal, because these things are going to automatically schedule across all the available cores you've got in your server. So if you've got a 32-core machine, awesome. It'll use them all. If you got this all running in a single sequential code, you're just going to use one core. And you can supervise that and use all the niceties that are built into OTP for that. And this is like everywhere in Elixir. So if you look through Elixir code, you'll see use Gen server all the time in application projects because it's really useful. But like all the core libraries in Elixir and a lot of the stuff in Erlang will all do this. So if you've used agents, they're just a thing for keeping track of some mutable state that's shareable across processes. That's a Gen server. You do tasks, which is spawning up one task or multiple tasks to process data, Gen server. Gen stage, Gen server, flow, Gen server, live view, scenic supervisors. everything you do in Elixir will be a gen server under the hood. Or if it's not a gen server, it's using basically the same pattern that might be hand-coded for extra speed or whatever. But essentially, if you see gen server, anywhere, if you see gen server, just think of that. Okay, use gen server means it's a separate process running. This thing is going to do over there, here's a separate process, and where you are in your process, where your thread of execution is going to send messages back and forth. It's a function that calls itself in an endless infinite loop, just sitting there waiting to receive messages and send back results. That does it asynchronously and fault tolerantly. And yeah, that's all I've got. So are there any questions? I'm going to say no.
In terms of like with gen server.
Oh, hang on. I will.
So in terms of gen server, then, if it's just running as a effectively like never-ending recursive program, then its system usage is entirely dependent on the inputs that come into it. In terms of its time response, would just depend on like how it can grow and grow in time response based on the longer it's taking the function to recurse, right? Like, yeah. So is there any like, do you have to set up anything around managing the size of the process effectively then? Or is the supervisor handling sort of killing it when it gets too out of hand?
So when you say out of hand, you mean like the stack size that it's running through?
Yeah, potentially, or like
the stack size,
the
okay,
processing time.
It's got a thing built into the runtime called tail call optimization. So if you have a recursive process that's calling itself, it effectively compiles down to a go-to function in the assembly. So a lot of languages, if you call the same function over and over, it'll eventually run out of stack space and blow up.
Yeah.
Elixir's fine with that. The Erlang runtime handles that perfectly happily. It does have some constraints though, because it is a single sequential thing. So that mailbox is essentially anyone can send a message to that mailbox, and it's going to process one message at a time and process it sequentially. Yeah. So if you take too long to respond to a message, everything else is going to bank up.
Yeah, okay.
So there can definitely be a point of a bottleneck in the system. So you've got to think about that, and then think, okay, well, if this is going to be a bottleneck, do I need a pool of these things? Should that work not be sent to a gen server to do it? So a pattern that would be really bad would be like if you had a calculator process, and you say, hey, add 1 and 2 together, and wait for the response back. And if you've got 100,000 processes all doing that, that's bad. So it might be better to just add 1 and 2 in the process where you're doing the work and not send a message across for that.
Okay.
So the best way to think about it is, this is actually a terrible example, the shopping cart. If you're building a shopping cart, don't do that. Like a shopping cart should not be a gen server. A gen server should be something that actually models a process. So something that is really changing what's happening in the real world. So a user session would make perfect sense as a shopping cart, and that might, or a user session would make perfect sense as a process, and that might contain a shopping cart. But the shopping cart should just be data in that process.
Okay.
And then if the user disconnects or whatever, or that session has a problem, you can rehydrate it from the database when it restarts, or just let it go, or whatever.
But you need to build your own timeout logic into a process if something like goes.
There is in gen server, in the actual nitty gritty of it, there is some stuff around timeouts.
Okay.
So if you send a message to it and it takes too long to respond, yeah, you can tell it to kill itself.
Okay, cool.
And then you can have some error recovery around that as well.
Awesome.
Cool. Okay. Well, yeah, we don't have any other talks tonight, and pizza isn't here yet, but it should be here shortly. So we might all wander back downstairs, hang out for a bit more, and then, yeah, have some food when it turns up, hopefully in a few minutes. Thank you.